Number 6 is a uniform circular motion question. They say we have a diagram below representing an 18,750 gram toy car moving at a constant speed of 6.4 meters per second clockwise in a circular path with a radius of 2.0 meters. 6a wants us to determine the magnitude and direction, north, south, east, or west, of the centripetal acceleration acting on the car at the moment it's shown in the diagram. So here's our little toy car. And they want us to find out which way the acceleration is pointing. Let's deal with that first, and then we'll actually calculate it. So the thing about uniform circular motion is that your acceleration, your force, and your velocity are always going to be pointing in the same fashion, right? Now, acceleration is always going to be pointing toward the center. AC, centripetal acceleration, always points toward the center. And if acceleration is pointing toward the center, well, then it only makes sense that force has to be pointing there too, right? Imagine you're pushing a box. It's not going to start accelerating in the opposite direction at which you're pushing it, right? You're not going to push it forward and have that box accelerate backward and run you over. That won't make any sense. So force and acceleration should always be pointing in the same direction, or at least net force, but in this case our centripetal force is our net force. So force and acceleration are pointing the same way. Now the weird one is velocity. Velocity should always be pointing tangent to the circle. The way I remember that is that it makes a 90-degree angle with your force and your acceleration, right? It makes this right angle right here. So velocity always goes at a right angle to force and acceleration. So in this case, they ask, which direction is acceleration pointing? Well, it's pointing toward the center, and we're right here, so it has to be pointing west. Which way is force pointing? That also has to be pointing west. Velocity has to be going north. Now you might be wondering, why did he make it going up and not going down? That would also be a 90-degree angle. But you got to think about which way we're actually moving. We show this little arrow right here, and it says that we're going counterclockwise. Excuse me, clockwise. Wait, it says we're going clockwise, but it shows it's going counterclockwise. I don't know. We'll go with the diagram, right? So we're going counterclockwise. We're going this way. The arrow shows us we're going this way. So velocity has to be going up this way, right? You can't be going in this direction at that moment and be going down. It wouldn't make any sense. So we have to be going up in order for us to complete that path. Now we can actually get into solving for the centripetal acceleration. Now we know the formula, AC equals v squared over r. Centripetal acceleration equals velocity squared over the radius. So to find AC, we plug in v squared, 6.4 meters per second, square that, put that over r, put that over 2 meters, and let's see what we get. Let me do that on my calculator real quick. 6.4 squared divided by 2, and what you should get 20.48 meters per second squared. Let's look at 6b. 6b says determine the magnitude and direction, north, south, east, or west, we already did that, of the centripetal force acting on the car at the instant shown. Actually, we should write it in. So this is actually 20.48 going west. So now let's find centripetal force. Centripetal force formula, Fc equals mac. Centripetal force equals mass times the centripetal acceleration. You could also do it like this, mc times v squared over r. I don't know why you would want to do it that way, because you know AC and it's going to be less steps. But if you wanted to, you could do it that way as well. That's another formula that could be used, because AC is v squared over r. So it's the same thing. So I don't actually think they give you this in your reference table, but we have used it in the past, so I figured I would mention it, in case you saw it in your notes and you're wondering when that comes up. But since we know AC, we'll just stick with this little formula right here. So Fc equals mac. They actually gave us a mass. They said the mass is 18,750 grams, but the thing is, we never deal with grams. 18,750 grams. We never deal with grams, we deal with kilograms. So we know kilograms, right? Kilo stands for 10 to the third. So what we have to do, divide this by 10 to the third in order to get it into terms of kilograms, and we get 18.75 kilograms is our mass. So what do we do next? Well, we'll just plug everything in. We know the mass now, it's 18.75 kilograms. We know the centripetal acceleration is 20.48 meters per second squared. We multiply those two. Let me do that on my calculator. 20.48 times 18.75. We get 384 newtons going west. That is your centripetal force. Now 6C, I didn't get on there at the picture. I couldn't get it all in one picture. But 6C was just asking for the direction of the velocity at the instant shown. So it's tangent to the circle. In this case, it's going north. So either one of those would be correct. I wouldn't really mind. The question specifies that you should say north, south, east, or west. But if you said tangent to the circle, that would be fine. So in this case, it is going north, though. So that would be 6A, 6B, and 6C.